The nth term, the general term, of a geometric sequence with first term a sub 1 and the common ratio r is a sub n equals a sub 1 times r raised to the n minus 1. This comes from the fact that we can look at the pattern of terms of a general geometric sequence and use logic and inductive reasoning to come up with the formula. So you can see what the first 5 terms of a geometric series would be, or sequence would be, and extrapolate what the formula for the general term of it would be. Now, a common ratio r is found by dividing any term after the first term by the term that directly precedes it. This ratio in general is a sub n plus 1 divided by a sub n. And if you're not sure what that means, not a big deal. We'll come to that in just a second. But that is what the form is for the ratio. Now let's look at some examples. We are going to find a sub 10, the 10th term, when a sub 1 is 4 and r is 2. So simple enough. All this is going to be is we know that n equals 10. So in our formula, we're going to have a sub 10 equals a sub 1, which is 4, times the ratio, which is 2, raised to the n minus 1, so 10 minus 1. And just do a little simplification, we're going to get 4 times 2 raised to the 9th. And instead of doing that 2 to the 9th so many times, we can just put that into a calculator and multiply it by 4. Just put the whole thing in. And we're going to end up getting 2,048. So the 10th term is 2,048. Now let's do another one. We're going to find a sub 7, the 7th term, when a sub 1 is 5 and r is negative 2. So again, n here is 7. So the 7th term, a sub 7, is going to be a sub 1 times negative 2, the common ratio, raised to the 7 minus 1 power. So again, a sub 7 is 5 times negative 2 to the 6. Throw that in the calculator to just make life easy, and we're going to end up with 320. So the 7th term is 320. Not too bad. Even if we get a fraction, we're not worried about it. A sub 8, the 8th term, when a sub 1 is 12 and r is a half. So again, n is 8. So a sub 8 is 12 times a half raised to the 8 minus 1. A sub 8 is going to be 12 times a half to the 7th, which again, throwing into your calculator, you're going to end up getting, it'll be a decimal, but you can always just convert it to a fraction, 3 over 32. So the 8th term of this geometric sequence would be 3 over 32. Again, simple enough. Now, we're given a sequence of numbers, 15, 30, 60, 120, and we're going to write the formula a sub n and use it to state the 9th term of the sequence. Well, we already know what the first term is. A sub 1 is 15 because it is the first number, but we still have to find r. Now, if you don't know what the formula is, or if you know what the formula is but not sure how it works, simple as this. You're just going to take 2 consecutive terms and we're going to divide them. It's always going to be the next term divided by the current term. So we can say that this is 30 over 15, which will give us 2. And you can see it's doubling, times 2, times 2, times 2, but this is how it would be more formally. So the nth term formula, a sub n, is going to be a sub 1 times the common ratio to the n minus 1. And that's all we're going to do for the general term. Now we can use it to find the specific part of this question, which is the 9th term. So a sub 9 And that a kind of looks like a 9. I'll rewrite it. There we go. A sub 9 is equal to 15 times 2 to the 9 minus 1. And again, you can just throw that in a calculator to make it look, or make your work a lot better. And you're going to end up with 3,840. So the ninth term is 3,840. Now let's do it again with a fraction, but we're not going to treat it any differently. Again, we know what the first term is. It is a 3. We don't know what r is, but we can easily figure it out by just taking two consecutive terms, which I'm going to do 3 and 3.5, or 3/2, excuse me, and write them as a fraction. So 3 over 2, since it's the second term, and we're going to divide it by the first term, 3. Kind of looks weird, but we're not too worried about it, because if you just work this out, you're going to end up just getting the common ratio, that is a half. And now we can just plug it into our formula, because that's what it wants, a sub n. So a sub n equals a1, which is 3, r, which is a half, to the n minus 1. And just like the last one, we're going to use it to state a specific term, in this case, the 11th term of the sequence. So a sub 11 is equal to 3 times a half to the 11 minus 1. And this, again, is just throw into your calculator and get an answer, which, depending on your calculator, it may not like it, but if you do get a fraction, you're going to end up getting 3 over 1,024. And if you cannot, the decimal approximation is 0.0629296875. But as a fraction, it would just be 3 over 1,024. And this is how you would find or work with the general term of a geometric sequence.